All right, for part 3, I want to run through some homework examples with you, what we learned in part 1 and part 2. I want to refer to number 7 on page 110 in our books. It's an assigned homework problem for you. We want to compute the range, variance, and standard deviation for the following car crash data. And let me briefly copy down the data for you. Again, these are dollar values of car repairs as stated in the text. 051, 6374, and 4277. So you can see this data contains 5 values of car repairs, so the data set is 5 elements deep, as you can see. All right, we want to compute the range, the standard deviation, and the variance. Well, the range, very simply, is the high value minus the low value, a very crude measure of center, and the high value is 9051, and the low value, it looks like 4277, and we grind that out with our calculator, and we come up with a dollar value of 4774 in dollars. Probably best to, oops, let me erase that. Probably best to give units on your answers. All right, so 4774 in American dollars. All right. All right. Now the standard deviation. All right. Basically, I'm going to use my one variable stats operator on my TI-83 calculator. Probably silly to not use it if it's available to you. Basically, clear out the old data, enter in this new data, and use the commands we illustrated to you last time, and we grind out a standard deviation, which is, again, little s in the literature, cap SX in TI language, and it turns out to be, well, again, rounded off somewhat, 126.8 in dollars. All right. I'll illustrate this in class a bit more when we meet face to face. For standard deviation calculations, best to use the one variable stats command if it's available to you. I will ask you to do the table method once on a written exam, but we're not ready for the written exam yet, so beware of that. You will use the table value. You will be asked to demonstrate the table method on a written test during our first in-class exam, but otherwise you're free to use the one variable stats command on your Texas Instrument calculator, of course. All right, so we've got the range. Oops, we've got the range. We've got the range. We've got the standard deviation. All we need is the variance. All right. Well, the variance is nothing more than the standard deviation squared. Now, again, this is subject to round-off error, and depending on how accurate you are, we'll talk more about that in class. Round-off error. I'm going to square 1926.8. That's in dollars, and I end up with $3,712,558.24. And actually, that's in squared dollars. I won't bother to put those units down. Those seem kind of abstract. Certainly, the standard deviation is the most important and most commonly used of these 3 measures of variation. Okay? All right, so that's an example from the homework, how to compute range, standard deviation, and variance. All right, now they also ask us in this data set, at the end of the question, they give us what we call critical thinking type questions. Is a cost of $10,000 for repair of a car unusual? Well, there is a criteria which we will use to answer that question, and picture tells 1,000 words. Basically, the criteria we're going to follow, more or less a guideline in this book. We've got a sample mean, which we can easily calculate. And I'm going to give boundaries high and low for this topic of usualness. Basically, if a data value is within 2 standard deviations of the mean, I call it usual, and anything outside of that range is unusual or not usual, right? Okay. All right. How am I going to apply that to this problem? Is $10,000 unusual? Well, let's see. From the data set, using the TI-8384, we can find that the sample mean of all those crash repair values is $6,412, and we know the standard deviation, as we calculated before, was $1926.8. So I'll create boundaries according to this scheme I've given above. Give me a minute here, draw it carefully. X bar is 6412. Excuse me. My upper boundary for usualness excuse me, be X bar plus 2s. That's 6412 plus 2 times 1926.8, and I get an upper boundary of $10,265 and about 60 cents. All right? So I'll call that my upper bound for the condition of usualness. Down here below, X bar minus 2s. If I take my 6412 value and subtract twice the standard deviation, I get a lower boundary, approximately $2,558.40, again in US dollars. Now, anything between these boundaries will be usual by our guidelines, right? So if I ask you, if we are asked, is $10,000 unusual? Oops. Get the eraser, hang on it. Is $10,000 unusual? Well, $10,000 lands us in the diagram somewhere not quite up to the upper limit of $10,265, which we have assigned. So we claim according to this criteria, let me write that down, according to this criteria, we say no. So your answer to that question would be no. $10,000 is not unusual. All right, you'll see several problems like this on the homework. Pretty much straightforward application of the examples you've seen here in parts 1 and part 2 and also part 3. Pretty straightforward stuff. All right, so let me give you your assignment for the online class 1. It's going to be to read section 3.3, pages 99 to 104, and then page 106. Okay. On to the exercises. Well, in our text, they call these homework exercises. I just call them the homework exercises. The book is a little more formal. Basic skills and concepts exercises. We get 5, 6, 7. We just did number 7 for you. 8, 9, 17, and 24. Yeah. All right. When asked for standard deviation, use the TI-8384 when possible. especially when computing standard deviation, and we'll talk more about the table method in class. All right, the online exam 1 will cover, as we stated in class, section 3.2, and that was covered in a face-to-face class, as you'll recall, and section 3.3 was covered in here online. Okay, so be sure to read and do your homeworks for section 3.2 and 3.3. Read all the necessary materials included in the online class folder, and when you're ready, complete the online exam. Remember, the online exam is due Tuesday, I believe that's September 4th, at 11:59 p.m. Okay? All right, so we'll call it a day with these 3 micro lectures, and we'll see you all face-to-face on Wednesday, September 5th.